All right, so today we're talking about two-step equations, meaning we're combining the addition with subtraction and the multiplication and division all together as one. So when I'm talking about this, I'm going to give you some steps, okay? So steps to solve two-step equations. Steps to solve two-step equations. All right, so step one, you want to get rid of parentheses, okay? How do I do that? Well, you might have to distribute, okay? It might be distributing the 1 in front of the parentheses. It might be distributing a negative 1 in front of the parentheses. It might be distributing just a number in front of the parentheses. It could be distributing a variable in front of the property, but chances are you may need to distribute, okay? Heck, you're going to come into points where you're going to have to do multiplying polynomials into it, all right? Those are things that are going to probably happen down the road. What's step two? Step two is to combine like terms on the same side. So keep the left with the left, the right side with the right side, leave them be, okay? 3. Actually, you know what? Let me do this. I didn't like that. 3. Get all of the variables to one side, typically the left side, and get all just the numbers, not variables, numbers to the other side, okay? And with this, you're eventually using inverses, okay? And then step 4 is to solve, which is also using inverse, okay? All right. So let's do some examples, all right? So we already talked about addition. We're already talking about multiplication and division, all right? So let's just jump right in and see what we're going to see, okay? So example 1. So the first one I wanted to bring up was this. Okay? So over here, step 1, get rid of parentheses. There are none. Step 2, combine like terms on the same side. Meaning, over here, what I'm going to do is I'm going to combine like terms just on this side, right? Because that's just one side. However, you know that this is a 1 in front or 1 over 1 in front, right? So I got add fractions. Oh no, everything's all coming all together at once. So I got to add fractions. So essentially, I got to add the 1 with the 1/5, right? So let's bring this to the side here. Okay. So I have a 1 over 1 plus 1/5. I need like denominator, common denominators. So it's going to be a 5. So what I have here is a 5 over 5 plus a 1 over 5, which makes sense, right? 5 over 5 would be 1. Okay, cool. So this is going to be 6 over 5. Okay, perfect. So the left side, let me finish this up right here. Draw your line. Move it. Yeah, close enough. All right, so on the left side, I want to have a 6 over 5x is equal to 36. Okay? So I combine like So I did step 2, combine like terms on the same side. The right side had nothing to combine. And then step 3 says get all the variables one side. Well, the variables one side. And get the numbers to the other. Okay, so 36 is on the other side. Awesome, I did that. So step 4 says solve using inverse. Well, how do I get x by itself? How do I get 1, positive 1x by itself? So I'll have to multiply this by 5 over 6. So I'm going to multiply this by a 5 over 6 and pretend that this is over 1. All right. So we ask ourselves, does anything go into 36 and 1? Yes. No. So does anything go in 36 and 6? You're just like, yeah, it does. It would be 6. So 6 goes into 6 how many times? Once. Goes into 36 how many times? 6 times. Awesome. Look, my denominator is a 1. The top is 6 times 5. So that means I have x is equal to a 30. Okay. And there goes my answer. Not too shabby. All right. All right. Let's see. Ooh. So now we're going to get to see a little bit more of what I mean by step 3 here. Okay. So let's see here. Another example. And we'll say this is 3y minus 3 plus y plus 31 is equal to 5y plus 30 minus 3y. Okay, so a little key here, guys. Take a look at this. So if I was to remove one of these and move it to the right side, okay, then I have to do it to both sides. If I have to do it to both sides to get rid of it so that it becomes 0 or becomes 1, then I would have to do the inverse. But if I stay on the same itself on the same side, then I do not need to do the inverse. So over here, I gotta collect my like terms, okay? Because I don't have any parentheses. I do have like terms, so that's what I'm gonna do. But since it's all one side, I'm actually adding them together. So what are my like terms? I have 3y and y. And then I have the negative 3 and the positive 31, okay? So over here, I get a 4y minus a 28, okay? So notice it's on the same side. I am just taking it as is, just adding them together, okay? On the right side, I do also have like terms. And my like terms are 5y and negative 3y. And the 30 is by itself. Awesome. So I have a 2y plus 30. Okay? So I just combined like terms. That's step 2. Now let's get to step 3. Okay? So here's my goal. Let's use different colors here. So I'm trying to get both of these on the same side while I get the numbers on the other. Okay? So, in other words, I want the 2y over to the left side. So the 2y, I would use blue here. The 2y, in order to get it over to the left side, I would have to add the inverse. There's a positive 2y, so I subtract 2y. If I do it to the right, I gotta do it to the left. So that this way on the right, it becomes a 0. Okay? So that's gonna give me a 2y. Okay? Now, I want to get that negative 28 to the right side. Okay? So it's negative 28, so I add 28. If I do it to the left side, I gotta do it to the right side. When I do that, look at what happens to that 28. It goes to 0. Okay, so it's no longer on the left side. Now it's on the right side. And that is going to be a 58. Okay, so now I have a 2y equal to 58. So I probably should wrote here, when we get all the variables to one side, I probably should say using additive inverse, while solving would probably be more of the multiplicative inverse, okay? All right, so now what do I do? Now I'm going to divide by 2, so that I have y is equal to, anybody? 29? Is it? Yes, it is. Yes, sirree. There we go. All right. I hope that explains a lot. I hope that makes it pretty clear for you. You're like, it is, but how about those parentheses? I'm like, ooh, good idea. I like your thought process. So I'm like, okay, let's do another example. Okay. Now, again, this is where, because this is a video, right? There's no problems with you just hitting pause after you write down after I write down the problem, hit pause, do it on your own. And then go, okay, let me see if I can do it on my own, right? After you do it on your own, now play the video and see if you got the right steps going. You got the steps right here. You also have the PDF of this. So you're gonna have all of these steps right there in front of you. So practice those steps. The more you practice those steps, the more natural it's gonna come, okay? All right, so let's do this example. So let's say I have 8x minus 2x plus 5 equal to 31. Let me draw this line here. Now you can pause the video if you want to. So I can extend this one down further. All right. So you just pause it for like 5 minutes and now you're gonna hit me on play again. So right here, I want to get rid of that parentheses, right? So what you gotta understand that there is really a -1 right here that needs to be distributed, which would get rid of that parentheses. So what I would have is an 8x minus 2x minus 5, okay, is equal to 31, all right? And as I had up here before, I want the numbers on the one side, while I have the variables on one side. Ooh, excuse me. And if you notice, the variable is already on one side. That's gonna give me a 6x. But I gotta get rid of that -5, so I gotta do the additive inverse, which would give me a 36. Then I have to finish this, divide by 6. So x is equal to 6. Voila. Not too shabby, right? I'm sure you guys did it right too. Perfectly right. All right. Let's see here. I want to do a few more problems. Yep, literally a few more problems. All right, let's do another example here. So here, I have 3 over 11x minus 1/3. Wow, that's awful. 1/3 x equals 4 over 9x plus 1. Okay? So I draw a line in between where the equal sign is, right? All right, so no parentheses. Combine like terms. All right, so I got combine like terms on the left side here, okay? And then I got so many fractions. Oh, what do I do? Okay, so here's what I'm gonna tell you, all right? So let's get rid of fractions. Now, I know that up here we dealt with fractions, but a little bit easier to deal with. Oh, not right there. Oh, I guess on the previous notes, we had to deal with fractions and it was uncomfortable, but we kind of dealt with it. Okay, now this is more fractions, so now it gets even more uncomfortable, right? So here's what you can do. What you can do is make this one a 1 over 1. Make it a fraction too, right? If there's 3 fractions, might as well make a fourth. What you can do is say, okay, what I want to do is I want to make all the denominators the same for all 4. Okay? I want to make it all the same. All right. So this is what we're going to do. We're going to do a sidebar here. It's 11, 3, 9, and 1 are my denominators. Okay? Actually, you know what? Let's do it right here. Okay? Let me do the 11. 11 comes out to be 11 times 1. Let me do... green. 3 is just 3 times 1. Let's do the purple. And we need the purple pen. Let's add a pen and let's make it purple. There we go. All right. So 9 is 3 times 3. And the 1 is just 1. Okay. So again, you have quadruplets, right? They all want the same thing. What did one have that the others don't have, right? So if I was standing here, what do the rest of your sisters have that I don't have? Well, doesn't have a 3 and a 3 and 2 3s basically, right? Because if you look at it, this sister has 1 3, she has none. This sister has 2 3s. She doesn't have neither 3, right? So okay. So what if sis stands here? What do they have that I don't have? Well, this sister here has an 11. This sister here has another 3, a second 3. Right? We're not really worried about this sister. This sister apparently doesn't have anything. Okay? She's one of those selfless types. So what if I'm this sister here? Okay? This sister has an 11. And if you look at anywhere else, she has more. She has 2 3s. She's the one that had the 2 3s, right? That everybody else don't have. Okie dokie. And what if I was this sister here? This is going to be like Christmas to this sister, right? So she needs 2 3s and an 11. Okay? So let's look at this. If you right now look at this sister here and, oops, not that one. This sister here and this sister here, if you look at all of this right now, including this, do you agree that each sister now has 2 3s and an 11? Yes? Okay. So now what we're going to do is we're going to multiply top and bottom by those numbers. So I want to multiply this bottom by 9, because 3 times 3 is 9. I'm going to multiply this bottom by 33. I want to multiply this one by an 11. Basically what's in red, that's why I'm using red. And multiply this one by a 99. I was just about to continue with a song, but I won't. All right, so let's bring this down. So what do I have now? I have a 27 over 99x minus 33 over 99x is equal to 44 over 99x plus a 99 over 99. Okay? So, here's the reason why I did this. Now, if you notice, all the denominators are exactly the same. Is that right? Okay. So, if I was to say to you, hey, I have x over 5 is equal to 2 over 5. You would tell me that the answer is x is equal to 2, right? Because the denominators are the same. What can x be? So what you did was you looked at this piece right here, and you told me that x is equal to 2. Well, same idea works here as well. Since I got all the denominators to be the same, that means that here is the equation I can write. You're like, what the heck are you doing? So in other words, I can write as 27x minus 33x is equal to 44x plus 99. Okay, everybody see that? All right, so if I get all the denominators the same, I can just write the numerator or the top as my equation. Now this only works for equations and equations only, okay? So there we go. Now I can now go and follow these rules all the way up here, okay? So no parentheses, so I need to combine like terms on each side. So I gotta bring this here down further. Okay, so I gotta combine like terms here. So what is 27 minus 33? I get a negative 6x is equal to 44x plus 99, okay? So what did I do over here? X's were blue, all right? So now I go to blue. I want the x's to be on this side, while the number in pink goes on this side, right? Awesome. Notice that the 99 is already there, but I have to get the 44x over to the other side. So this way, 44x minus 44x goes to 0, leaving with the 99, and this is going to give me a negative 111. Whoa, what am I doing? What am I doing? How about a negative 50x? Okay. Then I gotta get the x by itself by a positive 1x, so I'm going to divide by negative 50. So my x is going to equal to a negative 99 over 50. Now I can't leave the negative on the bottom because we don't like negatives on the denominator. So I can either do it this way. Oops. I can either put it on top or put it in the center. These two are acceptable forms, but not the negative on the bottom. Whoa, that's too big of a box. Ruh-roh. There we go. Okay, so that's what we have. And you're gonna look at this fraction and go, ugh, that can't be right. Well, it can be right, okay? Not every one of my checks is, $2 million, 0.00 is $2 million and, some pennies in there. So it could be a fraction. It's okay. And no, I don't make $2 million. But anyways, let's go to the next example. Let's see. Ooh, let's make this our last example because I like this one. All right. 9 minus 9 times x plus 3 minus 5 equals 9 plus 3 times 9 plus 3, minus 3x minus 81. Okay, so look at this. 2 parentheses, 1 on each side, right? So first, oops, not that. I want this, draw as this line. There we go. So first, I gotta get rid of parentheses. So over here, over on this side, I'm looking at the -9 here, and on this side, I'm looking at the +3 here, and that needs to be distributed. Okay? It's just whatever's in front, immediately in front, okay? Not the 9 plus 3 gets distributed, just the +3. Just the 9 on here gets distributed, okay? So I got to get rid of radicals first. So if your tendency is to subtract the 9 here first and add the 9 and 3 here first, it's wrong, okay? Order operation says specifically parentheses. I can't do anything inside, so exponents. I don't have any. So the next thing is multiply, and distributing is multiplying, okay? So I have a 9. This distributor is going to give me a -9 minus 27 minus 5. Actually, you know what? I should probably not use these colors. I should probably use as, I'll use as green. Oops. How did that not get in there? Let's see if this is any luckier. Yeah. Okay. And then over here on this side, I'm going to have 9 plus 27 minus 9x minus 81. Okay. All right. So I got rid of the parentheses. Then I'm going to combine like terms on the one side. And what did I use? Numbers is pink, variables are blue. Okay. So I'm going to take the pink, no, this pink, and deal with the variables. Oops, I forgot something, first of all. This is x, okay. So variable here, oh, wait a minute, pink is numbers. So undo, pink is numbers. So I got the 9, the -27, the -5, the 9 on this side, 27, and the -81. And in blue is, oh look, they're all by itself anyway, so perfect. So on the left side here, I have a -9x. Now I have to go on the calculator and say, okay, I got 9 minus 27 minus 5, and I get a -23 is equal to. On this side, I still have a -9x is equal to 9 plus 27 minus 81, I get a -44. Oops, why is there an equal there? Why did you put, let me minus a 44, okay? Uh-oh, what the heck is going on here? What happened? It was away. What happened? Okay, so again, I want all the x's on one side while all the numbers on the other. Okay, so I have to add the 9x so that this would be 0. I have to bring the 23 over to the other side by adding 23. And that's going to give me a -21. And this is going to give me a 0, right? Because over here, that's going to give me a 0, which I wanted. This, however, turned out to be 0 as well. Not what I wanted, but it happened that way. All right. Now, whenever I have this, this is what I call a false statement. Meaning, is 0 ever equal to -21? No, 0 is never equal to -21. So therefore, since it's a false statement, that means there is no solution. Okie doke. Wow, you guys learned a lot today. Okay? Which really we are putting all of it together into one, right? Of what we learned previously. So I hope this helps you. If you have any questions, let me know.